Hi everyone! Welcome sa ating ginagawang discussions about mechanics of deformable bodies. In today's discussion, I have prepared for you two problems about axial deformation. The first one is an axial deformation on a bar whose cross-sectional area is not constant, while the other one is that I have prepared for you an axial deformation caused by its own weight. And here is our problem, guys. A 2-meter long homogeneous steel bar, which is in the form of a frustum of a pyramid, is subjected to an axial tensile load of 100 kN. The cross-section of the bar is a square having a dimension at the left of 100 mm by 100 mm, while at the right is a 200 mm by 200 mm cross-section. Using a modulus of elasticity equal to 200 gigapascal, find the total deformation of the bar. Guys, ito yung figure ng ating problem. I have here a frustum of a cone whose length is equal to 2 meters. The cross-section of the cone on the left is a square having a dimension of 100 mm by 100 mm. Samantalang dun sa kabila, we have 200 mm by 200 mm. This bar is subjected to an axial tensile load of 100 kN. And considering that we are given the modulus of elasticity of 200 gigapascal, we have to find for the elongation of this material. So let us imagine that we show the axial deformation that will be caused by this 100 kN load on this bar whose length is equal to 2 meters. I have made an animation on this deformation for us to be able to understand how it will elongate. And this is what will happen to the bar when stretched or when subjected to an axial load of 100 kN. You will see that there is an elongation on the bar. The bar has elongated by this amount, equal to a total deformation. The question is, how do we get this total deformation? Although we have the formula for finding the deformation, which may be taken as the product of PL divided by AE, but we have to remember that this formula is only applicable when the following conditions are satisfied. Just like what I have discussed in my previous discussion, this formula has limitation, and it only applies when the following conditions are met. And what are they? Una, sabi nga, if the material is homogeneous and obeys Hooke's law. Ang ibig sabihin nun, the material will not be subjected to a stress more than its elastic limit. And so that we will have the formula equal to PL over A. Now, is this satisfied? So, kung babalikan natin ang problem, it is mentioned in the problem that the material is homogeneous. Ibig sabihin, the first condition is satisfied. The second one is that if the load is axial, in order to create a uniform stress over the area. Now, if we are to go back to our problem, it is mentioned that the tensile load is axial, hence the second condition for this formula to be used is satisfied also. While the third one is that the cross-sectional area is constant all throughout the length of the bar. Dapat daw, yung cross-sectional area ng material ay constant all throughout the length of the bar. Now let us try to go back to the problem. It is mentioned in the problem that the cross-section is a square having a dimension at the left of 100 by 100 and at the right of 200 by 200. So it follows therefore that the cross-section of the material is not constant all throughout the length. As a matter of fact, it is indicated that the section on the left is smaller than the section on the right. Hence, we cannot use directly the formula PL over AE because the cross-sectional area that is supposed to be constant is not satisfied. And so for the third condition to be satisfied, we consider subdividing the entire length into differential strip, whose length is dx, so that if dx is very, very small, then the area over that length becomes constant and the equation becomes applicable. So para daw magamit natin itong formula, ang gawin natin ay i-consider natin that we divide this length into thin slices. That each slice would have a dimension equal to dx. And if that dx is very, very small, then the area of the cross-sectional area of that differential length will become constant all throughout the distance dx. And therefore, if that happens, we can apply now the formula of PL over AE in order for us to solve for the deformation. So that if you're going to consider a differential length dx at a distance x from the left and take that vertical strip as a free body diagram. Sabihin natin na i-consider natin na kumuha tayo ng differential strip dito na kung saan ang distance niya ay x mula sa left, and we consider that as a free body diagram. Let us try to take this part. Kunin natin siya so that this would have this area. This differential strip would be subjected to a tensile load of 100 kilonewton. And this area would have a side equal to S, and S, it will also be a square inside whose dimension shall be equal to S, where S is that distance or the dimension of the bar at distance X from the left support. So ito rin siya yung S na yun, di ba? And if we are going to consider the area therefore will become equal to a constant all throughout this distance dx, and that value is equal to S squared. And if we are going to express S in terms of X, now considering this illustration, if this distance is X, therefore the total length will be equal to 2 meters. And if you're going to consider drawing a line passing through this point and parallel to one side, if this side is equal to 100, therefore this side, this part from here up to that point is also equal to 100, and that this side, this part, or this dimension from this point up to that point will also be equal to 100. And if the total distance from this up to that is 200, hence this distance from this up to that will also be equal to 100. And let us assume that this distance from this point up to that point be called as ky. Therefore, we can see from the illustration that this side S shall be equal to the sum of 100 plus y. And so we can solve for the value of S by ratio and proportion considering this shaded triangle. And therefore, we can apply that y is to x, the ratio of the vertical side, this dimension of the triangle to this dimension x is proportional to 100 is to 2. The horizontal of this dimension to this horizontal distance. And if this will be simplified, makikita natin that y is equal to 50x. Makatuwid, kung yung y ay 50x, if this will be substituted here, ang ating s ay magiging 100 plus 50 times x. And as such, we can compute for the area to be a square, and this will be equal to 100 plus 50x quantity square. And so we have here our area. Therefore, that differential strip, itong differential strip na tinutukoy natin, having a length equal to dx, that is subjected to 100 kilonewton, will be or will have a very, very small deformation. And if we will take that small deformation be d lambda, or d deformation, the value of which shall be equal to d deformation shall be equal to p multiplied by dx over ae. And if we're going to consider our area that is equal to 100 plus 50x squared, so we can substitute that in our equation, and then we sum up. So that if we will sum up all the deformations, kung pagkasama-samahin doon natin yung lahat ng deformations of each of the differential length, taken starting from the left. Okay, mula daw dito sa left na ito, okay, pakita natin yung part na yan, na kung saan ang x is equal to 0 hanggang sa dulo. Okay, kunin natin sa isa yan, ano? Okay, hanggang sa dulo, na kung saan ang x natin is equal to 2. So what do we have? Anong meron tayo ngayon? Ang ating makukuha is the total deformation will become equal to the integral of PL over AE, na kung saan ang P natin will be equal to 100 kilonewton or equivalent to 100 times 10 cubed of a newton multiplied by L, which is equal to dx, divided by A, which is equal to 100 plus 50x quantity square, multiplied by E, which is equal to 200 times 10 cubed, okay, Newton per square meter. And so you will notice that this 100 times 10 cubed will cancel with this. And so what will happen is that 100 divided by 200 is equal to 1 half. And therefore this becomes 1 half times the integral of dx, okay, divided by 100 plus 50 times x quantity squared. So, pasamantala ay stop muna tayo dito. Pag-aralan muna natin how are we going to integrate this part. So, kung babalikan natin yung ating knowledge sa integration, if we will let this denominator be our u. So, if we will let that 100 plus 50x be our u, then what will be the derivative of this u? Our derivative shall be equal to 50 multiplied by dx. Now, if we're going to examine that for this numerator to become the exact derivative of the denominator, we need to multiply it by 50. And so if we're going to multiply it by 50, then the denominator must also be multiplied by 50 so that we have multiplied it by 1. Because 50 divided by 50 will simply be equal to 1. Sa makatwid, ano ngayon ang mangyayari sa ating equation? If we will simplify it, our equation becomes 1 over 100 times the integral of 50 times dx over 100 plus 50x squared. And if we're going to substitute that this 50 dx be our du, and 100 plus 50x squared be our u, then this becomes, can be rewritten in the form that we have 1 over 100 times the integral from 0 to 2 of u over, du over u square, or simply it will be equal to u to the negative 2 multiplied by du. Now, how are we going to integrate this? Kung marirecall natin, kung i-recall natin, yung tinatawag nating power formula of integration. Ano ba itong power formula of integration? We have, the integral of u to the n du is equal to u to the n plus 1 over n plus 1. So that if we will be applying this, the integral of this will become equal to, tingnan natin, 1 over 100, times, negative 1 over u. Because, if we are going to, add 1 to these exponents, becomes u to the negative 1 over negative 1. And that u to the negative 1 over negative 1 is simply equal to negative 1 over u. And this must be evaluated from 0 to 2. And if we will substitute back our u, which is equal to 100 plus 50x, therefore this becomes equal to 100 or 1 over 100 times the quantity negative 1 over 100 plus 50x, which shall be evaluated from the same limit of 0 to 2. And that if we are going to evaluate the limits of integration, then our total deformation becomes equal to 1 over 100, substituting the upper limit, that is equal to negative 1 times 100 plus 50 times 2. Then substituting the lower limit by subtracting the next limit, that is negative 1 over 100 plus 50 times 0. And if this will be simplified, the total deformation becomes equal to, what do we have? The total deformation becomes 1 over 20,000, or simply that becomes equal to 0.05 millimeter. And so that is our first problem, ano? And I hope that you are able to follow the solution to the first problem. Okay, take note that in this particular example, we are able to use the formula that is equal to PL over A, because what we did is to make our length be very, very small, so that, okay, within that length, the area will be treated as constant. And therefore, we shall able to have that formula. The second problem that I will be presenting to you is, okay, the axial deformation of an object that is suspended at one end, and the deformation will be due only to the weight of the material. And here is our, okay, second problem, guys. A round bar, 20 meters long, which tapers uniformly from a diameter of 300 millimeter at one end to 200 millimeter at the other end, is suspended vertically, okay, from the larger end. If the bar weighs 90 kilonewton per cubic meter, find the elongation of the bar caused by its own weight. So we'll be using that E is equal to 100 gigapascal. So if we're going to illustrate our problem, then the problem will look like this one. Okay, so we have here a bar having a length of 20 meters. The dimension at the top is equal to 300 millimeter, the diameter, and the dimension at the bottom is 200 millimeter. It is suspended having the larger end at the upper one, and therefore the lower end shall be at the bottom. The value of the modulus of elasticity of this material is equal to 200 gigapascal. So, lumalabas that in this particular problem ay mayroon tayong frustum of a cone. And I know that you are familiar with the formula for the volume of the frustum of a cone, di ba? Pero ang kalimitang naobserbahan ko, hindi naman sa lahat ng pagkakataon ay kaya nating tandaan yung ganung formula, lalo pa nga't ang formula ay hindi naman pangkaraniwan. Pero sigurado na madali ninyo natatandaan ang formula ng volume of a cone, hindi ba? So if you are familiar with the formula of the volume of the cone, then there is nothing to worry about how are we going to use for the formula of the frustum of a cone, because the frustum of a cone can be simply taken as the difference between two, okay, different cones. And this is what I would like you to follow by determining the formula for finding for the volume of the cone. Kasi mamaya in our discussion, bakit ko bibigyan ng emphasis yun? Kasi in the later part of this discussion, gagamitin natin yung formula for the volume of the cone. So, imagine muna natin, mayroon tayo ditong tinatawag na imaginary cone at the bottom para mabuo natin yung perfect cone, kasi siya ay isang frustum lamang. Kung duduksong natin siya sa ibaba ng isa pang maliit na cone, then lalabas na meron tayong isang malaking cone dito. Diba? Sa makatwid, itong volume ng cone, ng frustum of the cone, ay lalabas na difference ng malaking cone mula dito hanggang dyan. Diba? Okay, babawasin natin yung imaginary cone. Diba? So, kung if we're going to consider that, okay, kinakailangan maunawaan muna natin, ano ba itong distance ito, okay, altitude itong kay imaginary cone ito. Let us imagine that the altitude of that imaginary cone be called as h sub 2. And so from here, we need to compute first for the value of this h sub 2. Diba? And so, to solve for that h sub 2, how are we going to do it? We can do it by ratio and proportion. And how are we going to come up with the ratio and proportion? If we have here a cone, okay, the cone being proportional in dimension, therefore their sides must be proportional. As such, if we are to consider the dimension of the ratio of this, okay, diameter of the base of the large cone to the total altitude, which is equal to, okay, 300 to 20 plus h sub 2. Take note that this h sub 2 must be expressed in the same unit as h sub 1. which is equal to 20. And this will be equal to the ratio of the same side of the smaller cones. The smaller cones is here, and the height or the altitude of that smaller cone will be h sub 2, and this will be equal to 200 over h sub 2. So from this relationship, we can solve for the value of h sub 2 by cross multiplying. I will have here 300 times h sub 2 shall be equal to 200 times the quantity 20 plus h sub 2. And if we're going to distribute 20 here or 200 here, then we shall have here 300 h sub 2 minus 200 h shall be equal to 4,000. And then simplifying, solving for h sub 2 will be equal to 40. So lumalabas, itong ating imaginary cone ay mayroong total height or altitude of 40 meters. So bakit ko ngayon ipinakita? Kasi gusto ko munang ipakita sa atin kung sakali makalimutan natin ang formula of finding for the frustum, then we can find for the volume of the frustum by using the difference between the large cone, itong cone ito mula dito hanggang sa ibaba, minus this imaginary cone. Okay, so that checkin itong gagamitin ko ay para lamang ma-check natin yung ating formula. So that solving for the volume of the frustum of the cone using the formula, ano ba yung formula natin? So kung natatandaan natin, yung formula ng frustum of the cone is equal to 1/3 of the height multiplied by pi times the quantity r square plus r small r square plus the product of r, where capital R represents the radius of the upper base or larger base, while small r is the radius of the smaller base, and h is the total height of the frustum of the cone. So in this particular example, yung ating r square dito malaki will be the radius, which is this one, 150. Samantalang itong r naman na ito na maliit will be the radius at this point, which is equal to 100. And itong h na ito, tutukoy ngayon dito sa 20, kasi yun yung height ng frustum. And so we shall have here that the volume of the frustum shall be equal to 1/3 times pi times 20 times the quantity, 150 square plus 100 square plus the product of 150 multiplied by 100. And that if this will be simplified, we shall be having the frustum of the cone to be at 0.9948377. That is cubic meter. Paano naging cubic meter yan? Samantalang kanina, meron tayong dimension dito na 300 mm. So you will notice that if this will be simplified, if this term will be simplified, itong term na ito, because 150 and 100 will be in millimeter, so ang lalabas ditong unit ay millimeter square meter. So that for this volume to become meter cube, the product of millimeter square will be converted into meter by multiplying it by 10 to the negative 6. So that when this is multiplied by 10 to the negative 6, ang lalabas na unit natin is cubic meter. Diba? So yun yung ating volume of the frustum of the cone. Take note that this volume of the frustum of the cone was taken from this formula. Itong tanong sa palagay ba natin ninyo, you can always remember this formula? Sabi ko nga, may mga pagkakataon na we can afford to forget the formula. Kasi pag masyado tayong maraming minememorya, maaaring mag-overload yung ating brain, So, hindi rin natin mapapakinabang yan later on. So, maganda, tandaan na lamang natin, if we have a frustum of the cone, if you cannot remember this formula, then we use the other formula. And how are we going to use the other formula? The formula, ganito. The volume of the frustum of the cone can be taken as the volume of the large cone, itong malaking cone ito, diba? Minus the volume of the small cone. Ito namang maliit na cone na yun. Diba? And so if we're going to solve for that volume of the frustum, ano ba yung ating magiging area? Ano ba yung volume ng large cone? That is equal to 1/3 of the height multiplied by area of the base. This 60 is the height, the total height from 420, the sum of 20 and 40, and that is equal to 60. And this is pi times 300 square over 4 is actually the area of this circular base, diba? Minus the volume of the smaller cone, and the smaller cone is actually our imaginary cone whose base has a diameter of 200 and an altitude equal to 40. And this will be equal to 40 over 3. That's 1/3 of the height multiplied by pi times 20 squared divided by 4. And again, this product will have a unit of millimeter square meter. And for it to become a meter cube, so we have to multiply. We have to convert that millimeter square into meter square. And that can be done by multiplying it by 10 to the negative 6. And as such, our volume of the frustum will be 0.9948377 cubic meter, which is just the same as the volume when we take the formula. Okay, ginawa ko lang ito para medyo magkaroon tayo ng recall or review of how do we get the volume of the frustum of a cone. Itong tanong, bakit ko pinakita yun? Kasi nga, gagamitin natin mamaya. No? So, ituloy natin. If we are to consider a differential thin plate at y distance from O, which shall be treated here as the apex of the circular cone. Ano ba yung circular cone na tinutukoy? Itong kabuuan cone ito, if we will be treating this as our O, diba? And we consider that at distance y from O, somewhere here, puntahan natin itong point na ito, okay, that this distance is equal to y, diba? And so, we consider this and we try to isolate this as FBD, we shall be getting here a very, very thin circular plate. The circular plate, therefore, shall be subjected to an axial load. This W, which will represent the weight of this frustum of the cone below this thin plate. And this will be equal to, sabihin the weight of the frustum of the cone below that circular thin plate. And how do we get this weight? Kung titignan natin ito yung frustum na makikita natin dito. Ito yung nire-represent natin itong frustum na ito. How do we get this height? This height of the frustum of the cone, which is this one, shall have a value equal to this distance. Mula dito hanggang diyan. And that is equal to this amount. Which when we are to observe the value, it will be the difference between y and 40. And so that distance or the height of that frustum is measured from the apex to be equal to y minus 40. And because we are now given the height of that frustum, and what we need to determine is to get the area as well as the other dimension of the frustum. So if we're going to consider this W, this weight shall be resisted by a tensile load that is exerted by the upper part of the frustum, and therefore this thin plate is subjected now to a tensile load equal to W. The distance of the diameter of this plate will be defined as x, while this distance or this diameter shall be equal to 100. And this area, this shaded portion, will be the area of the circular plate at any position of y. So that if we're going to consider that this thickness be very, very small, and we call that this thickness as this of y, that represents the length of the thin plate, then the total weight W that will be acting on the thin plate, which shall be equal to the product of the unit weight multiplied by the volume. And since we are given the unit weight to be 9,000 or 90,000 Newton per cubic meter, that's actually 90,000 Newton per cubic meter, multiplied by the volume. Itong volume na ito na pinakikita natin dito, ito yung volume using the formula, na kung saan we have the height over 3, where the height is y minus 40 divided by 3, multiplied by pi, times x squared, representing the radius of the upper base, plus 100 representing the radius of the lower base, plus the product of the two radius. That's 100 multiplied by x. And this becomes now the total weight. This weight will now be causing a deformation on that differential y or dy. Now, if we're going to express x in terms of y, so that using the relationship, this portion. Kunin natin itong triangle na ito, di ba? Nasaan ba itong x natin? Ang x natin tinutukoy ay itong distance na ito. Okay? The diameter of this, the radius of the triangle at this point, or the cone at this point, is equal to 100. And therefore, we can use the ratio proportion that x is to y. Okay? The radius is to the total altitude of that cone is proportional to 100 is to 40. And therefore, x will be equal to 2.5 multiplied by y. Now, if x that is equal to 2.5 multiplied by y shall be substituted here, dito sa value nito, then we are able to express w in terms of y. Diba? So, let's do it. Substituting x which is equal to 2.5y in w, what are we going to have? Okay, kunin ko lang yan. I will have here, dito ko lang substitute sa x ito, no? I will have 9,000, kinopya ko lang ito. Kinopya ko rin itong bahagi ito. Pi times y minus 40 divided by 3 times x squared plus 100 plus 100. Actually, ito yun. Isa-substitute natin ngayon itong x, okay, which is equal to 2.5 dito. So, our equation becomes, okay, this value of x becomes 2.5y squared plus 100 or 250y. Now, if we're going to distribute, okay, y minus 40 in this term, diba? Taking out the product of the constant, that is 9,000, okay, 90,000 divided by 3 is actually equal to 30,000. So I will have here 30,000 multiplied by pi. 30,000 comes from 90,000 divided by 3. Then if this y is distributed all throughout the 3, then I will have, okay, I will have here the following: 6.25 times y cubed, the product of 2.5 square multiplied by y will be 6.25. Then unahin ko lamang itong 250, ano? 250y multiplied by y is 250y square. Then plus 100 square is 10,000 multiplied by y is 10,000. If negative 40 shall also be distributed to the individual term of the second term, ano? So I will have here 40 times 2 and 2.5 is equal to 2.5 square, by the way, is equal to negative 250 y square. While 40 multiplied by 100, okay, by 250y is equal to 10,000 y. And 40 multiplied by 10,000 is 400,000. And so you will notice that, okay, this y square, ano, will cancel, will be 0, because 250 minus 250 y square will be 0. Similarly, I will also have this one, 10,000y minus 10,000y will also be equal to 0. And we will have a value of y or w to be equal to 30,000 times pi times the quantity 6.25 y cubed minus 400,000. Take note that this is our, okay, weight, okay, which shall be expressed in terms of, okay, kilonewton, okay, the product is kilonewton per cubic meter multiplied by millimeter square meter. So for unit to be cancelled, we have to multiply it by 10 to the negative 6. Para pag sinimplify yan, ang matitirang unit itong W will now be in Newton. Ano, magiging Newton yan. Take note that this W, and this is the one causing deformation on the very, very thin plate. Now, what about the area? What about the area? If we are to solve for the area of the circular plate, we know that the area of the circular plate will be in the form of a circle having a radius equal to x at that point where y, okay, at that point of y measured from, okay, the apex. And therefore, our area becomes simply equal to pi times x squared. But again, what is our x? If we're going to substitute the value of x, which is equal to 2.5y, therefore our area becomes equal to pi times 2.5 y quantity square. And therefore this becomes equal to, okay, and if this will be substituted in the formula for the deformation, okay, the deformation will have, Okay, a formula equal to PL over A. Let us substitute one by one. What is our P? Okay, we're going to substitute that. Our P will be equal to 3,000 times pi. This is the value that we have. Okay, times pi times 6.25 y cubed minus 40,000 times 10 to the negative 6. But this is in Newton. What about our L? Our L is the length, which is equal to dy. Okay, our L is equal to dy divided by our A is equal to pi times 2.5 y squared, or simply that's equal to 6.25 y squared. That's equal to pi times 2.5 y squared. Again, this will be in millimeter square. If this will be multiplied by times 10 to the negative 6, this becomes meter square. Okay, divided by E, which is equal to 100 times 10 to the 9 K Newton per meter square. So when this will be simplified, okay, we will have pi will cancel, okay, 10 to the 6 will also cancel. So what do we have here is, okay, 30,000 divided by 100,000, okay, 6.25 times 100,000 times 10 to the 9. 100 times 10 to the 9 multiplied by the quantity 6.5 y minus 400,000 y squared multiplied by dy. Now, let us now try to consider, no? Okay, if we are going to consider, okay, taking all those very, very thin plates starting from this bottom of the first room, okay, where the value of y is equal to 40, up to the top of the prostrum, where the value of y will be at 60. Diba? Pakita natin kung take tayo mula dito at kunin natin yung lahat ng differential length hanggang sa dulo. At pag pinagsama-sama natin yan, ano yung ating magiging equation? Ating magiging equation is integrating, integrating this term from 40 to 60. And this will be integrated also from 0 to the total deformation. And so this becomes now equal to, okay, our equation becomes, total deformation becomes the product of 30,000 divided by 6.25 times 100 times 10 to the 9. And this would have an integral equal to 6.5 y squared over 2 plus 400 over y evaluated from 40 to 60. And if you're going to evaluate the limits of integration, the total deformation becomes 1.4 times 10 to the negative 4 meter, or simply that is equal to 0.14 millimeter. I hope guys that you're able to follow the examples that I have presented to you. At sana ay patuloy niyo akong sundan sa mga susunod ko pang discussions about mechanics of deformable bodies by subscribing to this channel. And if necessary, share this to your friends so that your friends will also be notified of these uploads. Once again, thank you very much for watching.